In diagramming graph questions, you're asked to understand information about a graph and then use that information to either answer questions or build a new graph. In this case, we have an acceleration versus time graph and some initial information. Using that acceleration versus time graph, we can build a velocity v time graph off of that. We'll start by going in initially 1 meter per second, or negative 1 meter per second. So, and we experience no acceleration for that first second. So you just take it second by second, kind of build your graph from there. So no acceleration, but we are in motion. We are going negative 1 meter per second. Then we experience an acceleration of negative 1 meter per second, which means that our velocity changes in the negative direction. And then every second that goes by, we have a slope of essentially negative 1. It's kind of not a good line. Let me try to straighten that line out a little bit. There we go. Okay, and then we experience a new acceleration of positive 2 meters per second. So we'll come back up. Do it again. And do it again. Two follow-up questions we can ask on this are, what's your total distance traveled and what's your total displacement traveled? I don't think you'd be asked to build a position versus time graph since your velocities are changing. Those position versus time graphs would be curved lines, which would be hard to do. But we can ask, how many meters did you travel? So in order to do that, you'd go into that geometry mode and start building the geometric shapes in accordance to the shapes that are made here. For example, you have a square there. Finding the area of that square, you have traveled negative 1 meters in that particular second. Here we have a trapezoid. Area of that trapezoid being negative 4 if you go about solving for it. I see a triangle here with 4.5 being a particularly important second point. At 4.5 seconds, we have changed direction. Even though before that point, between 3 and 4.5 seconds, you have a positive acceleration, it's when your velocity goes over 0 that you're now changing direction and traveling in the other direction. The area of this triangle being, if you solve for it appropriately, 2.25 seconds on that triangle. So adding them all up, we have traveled in the negative direction with a total of 1 plus 4 plus 2.25, 7.25 meters. And then in a positive direction, this triangle here has a value of positive 2.25. So finally, we can say, well, what's your total distance traveled? Well, your total distance traveled, remember, distance doesn't care about directionality. Your total distance traveled in that particular case would be 1 plus 4 so total distance traveled there would be 9.5 meters. Then what's your total displacement traveled? Remember, displacement now cares about directionality. Very similar, only you kind of think about which values are negative. So that's negative 1, negative 4, negative 2.25. And you go in the positive direction. So your total displacement would be negative 5 meters.